All right, we're live. David, you can hear me, right?
Yes, sir.
Sweet. All right, well, welcome everybody. My name's Cameron. I'm the content lead over here at Tinybird, and I've got David Margulies as well. And today we're going to talk about user segmentation and specifically segmenting users in session at a pretty large scale. So we're going to be processing. We'll have a live example here where we're going to process, I think, a little bit over actually 1 million events per second and kind of do some basic user segmentation. Before we do that, just kind of want to, well, actually, first of all, if you have questions, feel free to, if you're watching this on YouTube, feel free to just type them in the chat. We can answer them while we're talking. This is pretty informal. Don't worry about waiting till the end. We'll just kind of answer questions as they come up. But this is kind of what we're going to go through. First, why in-session segmentation? Why does that matter? You might hear us use the term like real time. That's kind of what we're talking about. What does it mean to actually segment users during their session? And why is that important? And then David's going to do a quick intro to Tinybird. So if you're joining and you're new to Tinybird or you're kind of curious about it, that'll help. And then David's going to actually run an example. We're going to create an API while ingesting some events data from a kind of a game to actually serve to determine whether to serve ads to the user, and then we'll scale it up so you can see how that would work with like a high user concurrency. So kind of, what's the goal here? Why are we talking about user segmentation? I mean, the goal of user segmentation is to eliminate the guesswork, right? We want to, game developers or really, any application developer, any, company that's trying to serve campaigns to users is trying to put them into categories based on their behaviors, based on their characteristics, so that they can kind of determine what works for each group. And especially based on how they interact with your product, so that you can actually replicate that and get results. Like, the idea is if you can learn where your users are likely to spend money or click ads, and also when they're likely to do that. So where and when, and then actually respond to that as quickly as possible, it gives you a lot of power to drive more revenue. So today we're actually going to kind of talk very specifically about gaming and kind of even more specifically about mobile app game development, because this is really important where, you have a free app and the whole monetization strategy is happening in game. But, obviously this applies beyond that, but we're going to kind of focus on gaming. Especially, it's really interesting because there's generally a very high volume of events. So, kind of what we're trying to do here, what we're talking about in gaming specifically is to be able to alter the monetization strategy based on actions and characteristics. So there's kind of two goals. Obviously, there's a user experience goal, and really what you're hoping there is you're actually driving people to play your game more. And then also there's a revenue goal, right? How can we monetize this user, because that's what funds the game development. And so we're going to kind of talk about that. But one of the things to keep in mind, like when we talk about monetization, that there's often two ways that game developers will do that. And one of the most important tactics for game developers is to segment users into what we might call payers and non-payers. So there are some gamers who are going to be willing to actually pay money to do things in the game, to get power-ups, to advance levels, to do things like that. And then there are going to be non-payers as well, people that are never likely to actually pay. And so game developers, want to determine who's who. And so for those non-payers, a lot of times it's about serving them advertisements so they can actually monetize through that channel. And also just to make sure, sorry, David, go ahead.
Yeah, just one thing to add. I mean, that the user experience here is critical. And what that can mean with your monetization strategy is also not showing ads. You want to make sure that your segments are accurate enough where, you're not harming the user experience. You're not interrupting someone while they're playing.
Right.
I want to throw that in there.
Yeah, no, that's a very good point. Because obviously if people aren't playing your game, it doesn't really matter. Kike with the FIFA. Yeah. So, I mean, so my wife, I'm gonna talk about my wife here. She loves Candy Crush, and so I'm gonna kind of talk about this in the context of Candy Crush. I don't play Candy Crush, but I watch my wife play it very often because she plays it very often. One might say she's even addicted to it, but that's like kind of the point, right? But Candy Crush is interesting because it's a really good example of how a game developer, tries to do this. And so I asked her before this, I said, send me some screenshots of your game experience. And, so kind of over here on the left, it's like you're actually playing the game. And then when you finish the game, there's this moment where you as a user kind of get to decide what to do next. You can, go to the next level, but oftentimes there's kind of what you see here on the right, which is this option to, click an ad, play, see an ad. So you can kind of see there's like a play button there, and then there's a play with a little video icon. Hey, if you play and watch an ad, you can get the reward bonus or whatever. And of course my wife wants the reward bonus, so she watches the ad. But the important thing is, like, when you get to this point, you've got, maybe 5 to 10 seconds where you're on this screen, maybe even less. But you're kind of evaluating your options. Do I want to click play? Do I want to, buy a power up? Do I want to watch an ad? And as a game developer, you want to make the most of this critical moment. You need to choose what to offer to incentivize both more playtime, and then also, where to sprinkle in those revenue offers, whether it's, ads or purchases. And so we're like focusing really on that 5 to 10 seconds, right, where that user is right there in the session, and making the most of that. And so we talk about what it means to succeed in segmentation, what it means to actually to get this right. And of course, it's how accurate are your segments? How well can you actually measure who your users are, what they're doing, and then how effective are your tactics? Are you providing good campaigns? I think, you look at a game like Candy Crush and the success that it's had, clearly really effective tactics in providing offers that both enhance user experience and monetize. But then the important question of how quickly are they applied? One of the things you'll hear us say, or you'll hear, game developers say, and really any advertiser, it's about serving the right campaign at the right time. And in something that moves as fast as gaming, the right time might be 10 minutes ago. And so the goal here is, getting it to the point where we're actually serving the right campaign at the right time. And that also, like, and so what does that require? Like, what do you actually need to do to get that done? One is you need to be able to experiment quickly. So you define a campaign, and maybe it works or maybe it doesn't work. You need to be able to define that campaign, deploy that campaign, measure that campaign, and iterate really fast. And then continue to kind of iterate on that. But then also it's, what we're going to talk about here in a little bit is how would you do that while the user is playing the game based on actions that they're taking in that current session. And so, like, this would be like a common approach, right? Here's a common data stack, a common way that people might approach this problem. And so basically what you see here is, like, you've got an event stream. Maybe you're using Kafka or Red Panda or something like, and you're sending that data to a data warehouse. You're doing some modeling with DBT, setting up some Airflow jobs into putting this data into a low latency. Maybe it's a columnar OLAP like a ClickHouse or Pinot or Druid or something like that. And then you're publishing APIs so that you can then, serve that campaign back to the user. And kind of important to note here is that the color of these lines and this little legend down on the bottom right is just the time component here. And there's a slowdown that's kind of happening, in the data warehouse, and then moving that data into kind of a publication layer, where you're losing that low latency that you would need to actually serve that in session. So this approach has a lot of benefits. I mean, it's great for, you get this great view of your users. You can do a lot of that modeling. It's really good for things like BI or data science, machine learning. But one, you can't experiment very quickly. And then also you can't really apply what you're learning in session. Maybe you're applying it, the next time they play or the next day. But what we want to focus on today is actually applying it in session. And so what David is going to show you is something that's more like this. And that is, taking that data stream directly into a low latency data store that's actually doing the segmentation as events are being ingested. And then connecting that to a low latency API that's actually going to serve those campaigns. So, I'm going to hand this off to David, and he's going to kind of do an intro to Tinybird. If you're familiar with Tinybird, this is essentially what Tinybird looks like in a very condensed diagram and within this context. But the important thing that's happening here is one, you're speeding up, not only the rate of actually deploying the tactics. So with this timeline, we've got a bunch of blue lines representing milliseconds. So this is something that's actually happening in session, but also like the simplicity of the stack means it's more, it's better serving the user who wants to do faster experimentation, who wants to try new campaigns, develop things. And so it's a really interesting problem, and it's also a really interesting problem at scale. So when you talk about a game like Candy Crush, I don't know how many people play Candy Crush, but it's probably in the hundreds of millions. And so when you think about concurrency, the number of concurrent users and being able to do that, in real time, it's a pretty challenging problem. So David, I'll hand it over to you and kind of let you do the Tinybird intro, and then actually get into the example where we kind of show a version of this.
Yeah, absolutely. So yeah, it looks like everyone can see my screen. So yeah, thanks, Cameron.
Yep.
Like you said, I'm just gonna do a very quick introduction to Tinybird, and then we can get to the actual task at hand. So what is Tinybird? Right. Tinybird is a serverless analytical database with a set of developer tools that simplifies and accelerates your development over data. And really what that means is that with Tinybird, you can ingest data at any scale from any source, transform it just using SQL, and then expose that data through low latency APIs just with a single click. So I'm just going to show a very basic example. And so what you're seeing here is your Tinybird workspace. And a workspace is basically just a collaborative space where you can work with others on a specific project or use case. And there are two main concepts in Tinybird, and those are data sources and pipes. Data sources are where you actually ingest data. And like I just mentioned, it can be from virtually any source, whether that's a data stream like Kafka, remote URL, a local file, cloud storage, etc. Just for this quick example, I'm going to use Tinybird's events API, which is just an HTTP API endpoint that you can post JSON directly to. So you can see right here in the UI, we just have a sample snippet. So I'm just going to copy this and then switch over to my terminal. And when I run this command, it's going to post data directly to Tinybird. And so I'm just going to run this a few times just to simulate some sample data. And then I'll flip back to Tinybird. And you can see here that we have a new data source. So without having to predefine my schema or create a new data source in the UI, I was able to just send data directly to it. And Tinybird is smart enough to populate it for me. So this data source is essentially now a database table that I can interact with, that I can query, and on top of which I can build API endpoints. And the way that you do that in Tinybird is through pipes. So pipes are where you actually do most of your work in Tinybird. This is where you can explore your data, shape it, and enrich it for your use case. If you're familiar with Jupyter Notebooks for Python, Tinybird pipes are sort of like Jupyter Notebooks, but for SQL. So you can build out your queries incrementally. So I'm just going to do a very simple example. Let's just call it events example. So you can see here, I'll just leave it as is actually, because it looks like I already named something that way. So as you can see here, the data that I was just sending to Tinybird just has two columns, just the city and the date. So let's say in this example, I want to build an API endpoint just to count up the number of events per city. So the first thing I'm going to do is I'm going to select all the columns from events example, and I'm going to add a where clause to filter where city equals Chicago, and then run that. And so you can see here my result, I only have those rows where the city is Chicago. Okay. I'm going to rename this node to filter data. And then when I scroll down, you can see that there's a new node that's automatically selecting from that previous node. And so this is what I mean how you can work incrementally. This is just a very basic example, of course. You can do much more complex operations like joins, or really anything that you can do with SQL. So now in this next node, now let's do our aggregation. So I'm just going to count up the rows from the previous node, and I'll just call that n events. Run that. And then great, we see 5 events here. So this is the result that I'm looking for. And now the last step is to expose this data through an API endpoint. And to do that in Tinybird, it's as simple as clicking Create API Endpoint, selecting which node you want to output, and then boom, there's your API. And now this API is ready to integrate into your downstream application. All right. Cameron, is that a good intro?
I think that was good. I also think it's so funny that literally every time somebody's demoing, clicking the Create API button, you say boom, just because you just feel like you have to. So
exactly.
Nicely done.
The confetti it's fun every time.
Yep.
All right, great. So now let's get back to the task at hand, which is user segmentation. So you can see here that I have this one data source called game events. And this contains just a couple simple columns like the event type, the timestamp, and the user ID. So I pre-generated some of this data. You can see here there's about 4 million rows in this data source. And what these events are showing is as players are using the game, it's sending an event every time they do something like start a game, score, get to a new level, and so on. And so what we're going to do here is based on these events or based on a player's progress, we're going to choose whether or not to show that player ads. So for example, if a player reached level 10 and they haven't purchased anything yet, then we want to show them ads. Otherwise, we don't want to show them ads so that they can keep playing. So as I'm first going to build out our use case, I'm not going to worry so much yet about the performance or optimizations. Those are things that we can come back to. But hopefully this will give you a good idea of how quickly you can experiment in Tinybird. All right. So I'm going to now create a new pipe on top of my game events data source. And first thing I'm going to do is I'm just going to rename this pipe user. All right. And then since we want to base our ad logic on these different event types, let's just explore our data a bit and see what are those different event types we have. So like I mentioned, it's, we have game initiated. So once they started the game, once they've scored, once they hit a new level, and any events if they've purchased anything. So the first thing I want to do is count up how many events each user has for each of these different types. And in a real example, a gaming company would probably want to do this over several hours or several days. But since we're just doing it over this small period of time, I'm just going to aggregate all this data by minute. Okay. So first I'm going to go to my new node here. And let's just make sure I'm selecting from game events. And then I'm going to start with, so I'm first going to aggregate by minute. So to start of minutes, let's see, TS is my timestamp, and I'll call that T. I also want the user ID. And now I'm going to start counting up these different events. So first I'll just do a count just to get the total number of events. And now I'll need to do a count if, so I can introduce a condition to do my count. So I'll say count if event equals score, and I'll call this scores. Count if event equals, let me scroll up so I can see all of those.
I'll just add while you're typing, it's, if you're coming from like a Postgres or kind of a vanilla SQL, it's one of the nice things about Tinybird is, because it's built on ClickHouse, you get some of these nice aggregation functions with these modifiers that come with ClickHouse. So it's a nice function to have, especially in this case, as you type 4 of them.
Yes, exactly. All right, and hopefully I spelled everything right here. Okay, great. So now I have all these different counts for the different event types. And let me make sure to add my group by clause so I can group by T and UID. And then just so we can see some examples, let me just order by, let's just do total events descending. Run that. Okay, great. And let me just auto format my query just so it stays nice and pretty. Okay, awesome. So now for every minute, we have, and for every minute and for every user, we have the total number of events that they've generated, how many scores they have, how many games they've started, how many new levels they hit, and if they've purchased anything. So this is what I want to use now for my ad logic. Okay. So what I'm going to do is first, I'm going to rename this node. Actually, I'll just leave it as user one. And then I'll scroll down. And first thing I'm going to do is add a filter on the user ID, because we want to decide for every individual user, should we show them ads or not. Right? And I'm just going to pick one. Let's just pick this first one here. Okay, so I'll just copy that, make sure that's working. Okay, great. So now for this user, it looks like they were playing over 2 minutes. And now let me also add a filter. Actually, I'm going to leave that as is. Okay, so let's now so now we want to add in our actual ad logic. Okay. First, what I'm going to do is, looks like again I have to. I'm going to group by the user ID. So let me just pick user ID. Actually, just to simplify this, let me add in another filter just where T I'll equal this one, just so we're only looking at one. Oh, that's star. Great. Just to keep things simple. Okay, so now let's add in our logic. So just for the simple example, let's say that we want to show a user ads if they've played more than, if they've scored more than 10 points, and if they've not purchased anything yet. Okay, so what I'm going to do now is add in if scores are greater than 10 and purchases equals 0. 1 means yes, we want to show them ads, and 0 means no, we do not want to show them ads. And I'll just rename this column to show ads. And when I run this, I would expect to get 1, since for this one user, they have scored more than 10 and they have not purchased anything. Okay, great. So we do get 1 there. Now, just to make sure this is working, let's just check another user. Maybe it's someone that has not scored 10 yet. So let's go for this user. Okay, great. And we do see 0 there. So our logic is working correctly. And the last thing I want to do here is, you can see that I'm right now hard coding the user ID. So instead of this, we want to make our endpoint more dynamic. So what we can do here is introduce Tinybird's templating language so that we can add a parameter. So what I'm going to do, get rid of this, and use these double curly brackets for our parameter. And then we want to introduce an integer parameter. And I'll just call this user param. I'll add in that same user ID as my default. I can add a description just for documentation purposes. So I'll just call this user ID parameter. And I can choose whether it's required or not. Since I gave a default value, I can say required equals false. Okay. And so when I run that, I'm still getting the same result. And just to double check, let's go back to that first example. Make sure if I put this in the default that we get 1. Okay, great. All right, so now we have a working model for our query, for our ad logic. Now the last step here is to create an API endpoint. So again, click Create API Endpoint, select that final node, and then more fun confetti because now we have our API endpoint. Just to show how this is working quickly, I'm going to copy the URL and just open up a new tab. And you can see here that we get our result in JSON format. In the URL, hopefully it's not too small, here's where you can see our user ID parameter. So let me go grab another user ID, someone we expect to get 0. So I think this one looks good because scores is less than 10. And let me just put this into our URL parameter. And great, we get 0. So every time I refresh this page now, it's actually making a request back to the Tinybird API. And I can go to Tinybird and go to the View API page. And when I scroll up, you can see here that we have some built-in observability metrics. So that data being generated by calling the API is being fed back into Tinybird so that in real time, you can monitor the performance of your API. So you can see how many requests, how much data you're processing with each request, if there's any errors, and the average latency. So this is now, we have our working model, and it's working great with just a couple million events. I think we had about 4 million. But what happens when we start sending 1 million events per second, right? If I go back to my pipe, in this node here, you can see that I'm doing this aggregation at query time. So every single time someone makes a request to the API, it will have to run this aggregation. And as your data scales up, especially to the tune of 1 million events per second, this can really hurt your API performance, and it can get really expensive in terms of both resources and, of course, money. So how can we improve the performance and try to do this aggregation ahead of time? One really powerful tool in Tinybird is materialized views. So what I'm going to do first is just unpublish my API. And creating a materialized view is extremely simple in Tinybird. You essentially follow the same process that you would to create an API endpoint. So I'm actually just going to use the same query that I wrote in this node just to do my aggregation. I'm going to remove this order by. Great. And instead of making an API endpoint from this node, I'm instead going to create a materialization. So again, just go to the top right, create materialization, and then I'll select this user1 node. And no confetti this time, because we're not quite finished yet here. So what pops up here is just a couple options to configure our materialized view. So Tinybird automatically recommends your sorting key, which is essentially the index by which you'll query the data, and also the partition. And if you'd like, you can add a TTL, a time to live. Let's say you only wanted to keep your data for the past 30 days or whatever. So first, I'm just going to rename this to user. I'm just going to call it user count. And then I will click next. And now I can choose to populate it with a certain amount of data. So I'm just going to say previous and new data so that it will populate with all of the data I have so far. And then create materialized view. And what's actually happening here, so you can see that the materialized view is populating. And this is now just running one time over the data I have. But what's really unique about materialized views in Tinybird is that data gets materialized on ingestion. And so without having to schedule a job or set a trigger or anything, every time that a game events data source gets new data, it will automatically get materialized. And you can see this materialized view now has reduced by orders of magnitude the size of our data source. So down from about 4 million rows to about 2 million. And we've already pre-aggregated. We've done this calculation already. So now that we have this materialized view, we can treat it just like any other data source and build pipes on top of it. One more thing to note here, you can see that these values are showing as blank. That's just because of the way that Tinybird is storing this data. It's actually storing it in an intermediate state. And I'll show in a minute when I create a pipe that you can sort of force that aggregation to happen. All right. So now I'm going to create a new pipe. And let's call it user with MV, just to make sure that we're using the materialized view one. Now let's recreate that logic that I created. Okay, so first thing I'm going to do here, select T. Actually, first, let's just do select star again. So like Cameron was talking about when you're showing the slides, we really want to focus on that critical moment when the user is looking at that, that ad screen for just a couple of seconds. Okay. So why don't we add here a filter where the timestamp is within a certain range. Once we start sending more data, we can adjust this range. But just since I created this data a little bit earlier, let's just look in the past day, and then we can modify that later. Okay, great. And let's also add a filter on the user ID in this node. So let's say and UID equals, let's see, do I still have one? Great. Okay, so now let's do this aggregation so that we can force the merge of our data from materialized view. Here, I don't care so much about the total events, so I'm only going to look at those different event types. So I'm going to do the same count if, but here I'll have to add another word merge, which again is forcing that merge in the materialized view. Okay, so I'll count if merge scores as scores, and so on. Game started. Game started. Levels. Let's run that. Okay, great. And let me just auto format to make it look pretty. Okay, so let me just rename this node to user 0 to keep it simple. All right, and now the last step is to add back our logic to determine whether or not to show a user ads. Okay. So scrolling down to the next node, why don't we say if we can use the same example, and then we can add some experiments later once we start streaming in more data. So say if scores is greater than or equal to 10, and if purchases equals 0, then 1 means show ads, 0 means don't show ads. And we'll call this show ads. Okay, great. So for this example, I do expect to see 1. Let's go back up and add back in our parameter rather than hard coding it. I'll say int 32, call it user param again, give it a default value, give it a description, and I'll say required equals false. And again, I'll auto format. Just to show one thing with that parameter, when I scroll up, you can actually see that Tinybird automatically sensed that I added this new dynamic parameter. And so, as you're working, Tinybird is always helping with documentation. Okay, so we know that this example is working. Let's find a different example. So I'm just going to copy this query to a new node. And I'm going to remove the user ID filter. And I'll just add it back into the select statement. And I have to make sure to group by. Okay, so let's just pick a couple examples. Actually, first, why don't let's publish this as an API. Okay, so I'm going to create API endpoint, select the second node, and then there's our API. Let's again open up a new tab. Great. And here again, we can see our user parameter in the URL. Okay, so let's double check that this is all working as we expect. So let's pick another user ID. who has fewer scores and no purchases. Let's look at this one. And when I run this, I expect to show 0. Awesome. All right, so we now have a working model. And the last step is to start hitting it with data at about 1 million events per second. So Cameron, any questions before we get started with that?
No, I don't think so. You've been thorough, so it totally makes sense.
Okay, awesome. So I'm going to go back to my terminal. And I just have a simple script here that is going to be sending about 1 million events per second to that events API endpoint. So let me just kick that off. All right, and looks like it's going, and hopefully with the the live stream, nothing will go wrong here. All right. So first of all, let's check to make sure that this data is actually being sent to Tinybird. So to do that, I'll go and create a new time series visualization. And this is actually a new feature that we've recently rolled out that allows you to visualize some of your time series data directly in the Tinybird UI. So what I'm going to do is create a new visualization. I have to select a data source. So I'll choose my game events. And then all that you need is a date time column. So it automatically selected my timestamp column for me. And then I'll click create. And then you'll see here that we have a sort of SQL interface that you can use to build visualizations. So by default, it's giving me a count of all of the records coming in. It's showing me the last 7 days, but since we just started sending data, let me change it to 1 minute. And the granularity automatically set to 1 second. So you can see in real time that we're getting about 1 million events per second. And you can see how this is updating every couple of seconds. Just to show another interesting thing here, why don't we group by the different events so we can see how many games are being started, how many scores are happening. So let me do that. Okay, and now we have different colored lines for those different event types. So I think as makes sense, most of the events coming in are scores, as people are playing, and then people are also hitting new levels and so on. So this is a really powerful tool, sort of in real time, to be able to visualize how your time series data is working in Tinybird. So now let's go back to our API. So user with MV, and go to view API. So before, when we were just working over about 4 million events, our latency was about 10 milliseconds. So let's see. Hopefully, we're able to maintain that same performance. So let me just refresh this now. And yeah, looks like we're still operating in milliseconds. Now, as I refresh that a few times to make a few requests, and now going back to my API page. So yeah, so now you can see we're still under 20 milliseconds for all these APIs. And let's just go back and let's check how many events we're actually doing this query over. I'll select from game events, and let's just do a count. Yeah, we're already about at 174 million. And every time I refresh this, we'll see that count's going up. So 178, 181. As soon as that data is hitting Tinybird, it's ready to be queried. And our API endpoint is always querying that freshest data. All right, so now that we know that that's working, Cameron, any ideas for some experiments we could run here?
Yeah, I mean, I think just I think what we want to show like for a specific user, should we show them an ad or not? I mean, I think the important thing is like the limits of your logic is really right now it's just whatever the limits of SQL are with some things on top of that if you get into kind of the variables and the templating stuff. So yeah, I mean, we could develop anything. I think the important thing is this is a simple example either way.
Exactly. But yeah, I guess just to show another quick experiment we can run, why don't I duplicate this pipe? So it's going to have the exact same queries that we've already run. Instead of, let's switch up our logic here. So let's just look at our total counts and see if anything interesting pops up. So right now we're basing it on the number of scores. You probably don't want to show an ad every time someone scores a point. We probably want to base it on the levels instead. So why don't we go ahead and just update the levels? So let's say if a person reaches beyond level 10. So levels are greater than 10. And I think purchases still equal 0. If no one's purchased anything, then I think it's fair to show them ads. If they have purchased something, then maybe we don't want to show them an ad. So update that. Can create a new API endpoint. Let me make sure I'm doing it from the right one. And then just like that, we have our new API with our second experiment. And let's just double check that that one's working as expected. So for our default user, show ads is yes. Let me just type in some, well, let me go grab some examples. So why don't I add just a having levels less than 10. Okay, let's grab this example. And hopefully by the time I paste this in, that user has not reached level 10 yet. And great, so we're not showing that person ads yet. So that's pretty much all I had to share. By effectively using the materialized views, we're aggregating at ingestion time. And so with that, we were able to segment these users still in milliseconds to the tune of about 1 million events per second. And so hopefully this has given you a good idea of how fast you can experiment over this data as it's actually happening.
Yeah, I think it's really interesting too to look at, like, it was funny because when I was talking about Candy Crush, I mean, like when I watch my wife play Candy Crush, she's not on that page, that offer page, because she plays so much for more than 2 seconds, right? So I mentioned like 5 to 10, but the reality is, like, you need to have that millisecond latency to actually serve something at the pace the user wants to play. So it's
Exactly.
it's pretty cool to see that low latency on top of so many events. I think one thing I also want to say for those that are still watching is, what David has showed today is using the Tinybird UI, because it's really good for demos, and even some of the features you get in there, like the time series exploration. This is also supported by kind of a full featured command line interface too. It's really, what we typically tell people that start with Tinybird is, start in the UI, understand the concepts, and it's actually really good for doing what David just did, which is experimenting, trying new pipes, really quickly kind of deploying and trying and exploring and things. But then actually once you start to want to move things into production, that command line interface becomes really valuable. You can implement, different versions. You can, start to use whatever, if Git, is your thing, which for most people it is, you actually start to actually push these project files into Git and managing those versions there. So it's really easy to sort of develop these things, as a part of your application development. So it doesn't feel like this, separate, tool that you have to learn as much. It really fits within the flow. So, yeah, David, anything else you want to add? I mean, if anybody has questions, you can feel free to ask them, and we'll try to respond real quick. But anything you want to add, David?
Yeah, I think we pretty much hit on everything. I mean, I guess just to reiterate your point, even at this volume of data, it's still a pretty basic example. With Tinybird, you can do much more complex operations. I like to say you're really only bound by the limits of SQL. So you can, although I showed one example here of writing a query over one data source, you can introduce data sources, multiple data sources, and do things like joins, which is a really powerful tool to be able to develop over your data.
So we actually had a question that's not a dumb question. David, you might want to answer this, which is just, I don't know if you can see that.
So queries have to be defined beforehand, right? A consumer can't make a query or endpoint on the fly. No, that's actually a great question. So there are a couple different ways that you could address that, really depending on your use case. So what you expose in your API, yes, that is your predefined query. So let me see if I can show a different example here. Let me duplicate this again. So let's just say, this node is going to be our API endpoint. Okay, so I'm going to create this new node. This new API endpoint off of that node. And so by default, with this, I defined those 4 columns that a user can see. But there is actually a way, if I copy the URL again, you can actually add in a query into your API URL. And hopefully I'm doing this right. So after the question mark, I'm going to add in a Q, Q equals, and I'm going to select, and let's just say we want to select just scores. So the user would only be able to see scores in the endpoint. So select scores, and hopefully that's right. No, I did that wrong. I think I need to say select scores. And yeah, I think I'm doing this one wrong, but I guess short answer is yes, there is a way to add in your queries to that API URL. I apologize for not being able to show that here.
All good. I think you answered the question. It's definitely doable. I don't, unless there are other questions, I think we'll kind of wrap up. If you do have other questions as you're using Tinybird, feel free to hop into our Slack community. We're very active there, helping people out. Otherwise, thanks everybody for joining, and we'll see you soon.
Thanks, everyone.
Bye, guys.